Hello students, welcome to the online lecture series of St. Andrews Institute of Technology and Management. Myself Satendra Vats, Assistant Professor in ETC Department. In today's video we will see some basic signal functions that we will use throughout the syllabus of signal systems. So it is a part of unit 1st of signal systems of EE 4th semester. So let's see some basic signals. First is the unit impulse signal. So it is denoted by delta t, where t is the time and it is the variable. So this is a one-dimensional signal which is varying with respect to time. So if we take a rectangular function xt whose width is e, that is minus e by 2 to e by 2, and the amplitude is 1 upon e. Okay, so if in this signal xt I somehow make e tends to 0, okay, if I make somehow e tends to 0, then the width of the signal, that is this e width, would reduce to 0, and the amplitude, that is 1 by e, if I put 0, it would tends to infinity. So the signal I get now is a impulse signal. I am getting a impulse at time t is equal to 0 of amplitude infinite and width 0. Okay, so this is how this function can be converted into a impulse and impulse functions. So delta t is limit xt e tends to 0. So delta t is infinite at t is equal to 0, that is at that point, and it is 0 otherwise, that is at all the values of time other than 0 the signal would be 0. So impulse function, that is delta t, is an even signal. It is a non-energy, neither energy nor power signal. That is, it is neither an energy signal, because in energy signal the energy is finite and power is 0, while in a power signal power is finite and energy is infinite. So it is neither an energy signal nor a power signal. Okay, if now we calculate the area under impulse, so as we can see, the area of this rectangular pulse is e is the width and 1 by e is the height. So 1 by e into e, which comes out to be 1. So similarly the area of the area under this impulse function or delta function would be 1. It would comes out to be 1 if I put minus infinity to infinity delta t dt, which is the area under the curve. It comes out to be 1. So now let's see some of the basic properties. That is, first is shifting properties. If it is the delta t function, if I shift it by time t1 or delayed it by t1, so it would look like this. That is, the value of the function would be available at t1 only, and before t1 and after t1 the value would be 0. So our delta t function is delayed by unit t1. If it was if it was delta t plus t1, then it would have shifted to the left, that is here. So this is minus t1, so value would be available at minus t1 only, otherwise it would be 0. Similarly, we can see the scaling property. If we have the function delta a is multiplied to t minus t1, a is a constant which is multiplied in the time domain, so the function we would get would be 1 upon a delta t, that is the magnitude would be divided by 1 upon a. Okay, now if let's see, we have a signal xt, and now if I multiply it with a delta function, shifted delta function, then what would I get is this function, that is x of t1, that is the time by which I am shifting my delta function would come out inside this, that is x of t1 into delta t minus t1. So we can see an example over there. If we need to calculate y2 is equal to 2 sin t delta t minus pi by 2, so I will take this xt is in this function is sine function, that is sine t. So I will calculate sine t at t is equal to pi by 2. So it would be 2 sine pi by 2 into delta t minus pi by 2. So sine pi is 1, so it becomes 2 into 1 into delta t minus pi by 2, or 2 delta t minus pi by 2. Okay, now if let's see another example. If we have e raised to power minus 2t square into delta 2t minus 1, so this is our xt. So I will calculate x of 1 by 2 in this, as I have taken 2 outside the bracket, that is 2 is taken common, so it remains t minus 1 by 2, that is the time is shifted by 1 by 2. So I would take x of 1 by 2 into delta 2t minus 1. So it would become, the value would become 1 by 2, as 2 is, I have taken 2 common, so it is the scaled version, so it is divided by 1 by 2, that is 1 by a. So 1 by 2 into e raised to power minus 2 into 1 by 2, as t is 1 by 2. So this is how we can calculate the value. So it comes out to be 1 by 2 e raised to power minus 1 by 2 into delta t minus 1 by 2. Okay, now if I calculate the value of this integral xt into delta t minus t1 from minus infinity to infinity, so it comes out to be x of t1. As you can see, it becomes xt1 into del t minus t1. If I, since xt1 is a constant, it comes out. So when I apply the limit minus infinity to infinity delta t minus t1, so it is the delta function. This is my delta function, its value becomes 1. So what remains is xt1. One more property is there. If I get a function like this, xt into nth derivative of delta function into dt, this is the nth derivative, so this would be equal to minus 1 raised to power n minus 1 raised to power n, and nth derivative of this xt, nth derivative of xt at, and we put the value at t is equal to t1, that is this value. So at t is equal to t1, I will calculate the nth derivative of xt and multiply it with minus 1 raised to power n. So this is how we can calculate. Now next function is unit step signal, ut. It is denoted by u of t. So this function is 1 for t greater than 0, that is it is 1, the amplitude is 1 for t greater than 0, and for t less than 0 it is 0. Okay, and we can calculate the value at t is equal to 0 using the Gibbs phenomena, which says the value of a discontinuous function at the discontinuity is the average of the value at that point, that is it would be the summation of the value at prior to 0 and the value at after 0 divided by 2. So it is the average of two values, that is before the discontinuity, that is at 0 before the discontinuity, and the value after the discontinuity. So it is discontinuity at t is equal to 0, so the value at 0 would be u0 minus plus u0 plus divided by 2, so it comes out to be 1 by 2. So value we would take at 0 would be 1 by 2. Now let's see some of its properties. Ut plus u of minus t, that is the time reversal function or the mirror image of this function, would become 1. So if we have a ut which is 140 greater than 0 and u of minus t, that is 140 less than 0 and 0 for t greater than 0, so this is u of minus t. Now if I add both of these functions, this one and this one, I would get a straight line with amplitude 1 from minus infinity to infinity. So ut is a power signal. As we have seen, the delta function was neither energy signal nor a power signal, but ut is a power signal because it is not limited to time. So it is not limited to time, it is varying from minus infinity to infinity. It is a power signal, so power of this signal would be 1, and as we know, the power is nothing but the average of the signals. So root mean square value would be 1 by root 2, which is nothing but the under root of this average value, that is the power. Okay, so average of this will be 1 by 2, and power would be 1 by 2, and RMS will be, as a root mean square is the, first we will take the, if I have a signal xt, then I will take square. Root mean square value can be calculated as, first take the square, then take the mean of the signal, and then take root. Okay, so this is how we can calculate the root mean square value. So it comes out to be the 1 by root 2. So derivative, if I will take the derivative of unit function, I will get the delta function. So this is a very important property. If I take the integration of delta function, I will get unit signal. If I take integration of unit signal, I would get a ramp signal, which is like this, RT. So okay, if I take the integration of RT, I will get a parabolic function. Okay, and if I do reverse, that is, if I will take the derivative of PT, that is the parabolic function, I would get ramp signal. Now if I take the derivative of ramp signal, I will get the unit signal, and now if I take the derivative of unit signal, I will get the delta signals. So next is Signum function, which can be defined as, or which can be drawn as, the signal is 1, it is 1 for t greater than 0 and minus 1 for t less than 0. So this is our Signum function, that is, the magnitude is 1 for t greater than 0 and minus 1 for t less than 0. It can be drawn as this. So power of this signal would be 1, RMS would be under root 1, that comes to be 1, and average is 0, as the half of the signal is above x-axis and half of the signal is above x-axis. So average would be 0 for these sort of signals, in which we get half of the signal over x-axis and half of the signal below x-axis. So all these sort of signal will be average 0. Okay, now see some of the properties of Signum functions. This, if it is our Signum function, so if I add 1 to this, so it would become this signal, that is 2 for t greater than 0, and this part would cancel out, and for this part it would be 0 for t less than 0, 2 for t greater than 0, and 0 for t less than 0. So it would become 1 plus signum t. So it would look like this. So 1 plus signum t is nothing but 2 times of ut, as ut is defined for t greater than 0. So 1 plus signum t is nothing but 2 times of ut, as the amplitude is 2. Or we can say ut is equal to 1 plus signum t by 2. Now next is ramp signal. So ramp signal can be calculated using the integral of unit signal from minus infinity to t. Since it is defined for 0 to t, so it would become ut 0 to t dt. So it comes out to be t into ut. So this is our, so ut means the signal t ut is defined for t greater than 0, that is this part only. So this comes our rt ramp signal t ut. So this is again neither energy nor power signal. Okay, now let's see parabolic signal. So it is the integration of ramp signal. So when I integrate it from minus infinity to t, I would get the ramp signals. Okay, so this is defined for both the cases, but if I take it as it becomes tut, so it would look like only this part, that is it is defined for t greater than 0. If I say t square ut, so it would look like this, or if I say only t square, so it would look like this. Both of these are parabolic functions, but t square ut is defined for only the right hand side, whereas if I say t square u of minus t, then it will be a function defined for the left hand side only. Okay, so power of this this parabolic signal, that is p of t, can be described as t square by t ut. Okay, now square signal or a square wave uh, would be it would be a square pulse of time period t. Okay, so its amplitude is 1 for minus t by minus t naught minus t naught by 4 to, that is minus t naught by 4 to t naught by 4, it is 1. Then it becomes negative for t naught by 4 to 3 t naught by 4. So this is our square signal or square pulse with amplitude a naught and time period t naught. So its power comes out to be a naught square. RMS would be the square root of this power, that is a naught, and average comes again 0, as half of the signal is below x-axis and half is above x-axis. So the average would always comes out to be 0 in these sort of signals. Now triangular wave, we can have a triangular wave which looks like this, having a time period of t naught. So again, the power of this signal, you can always calculate power because it is the average or the mean square value of this function. So it comes out to be a naught square by 3. RMS value would come out to be a naught square by 3 under root, so it would come a naught root 3, and average will again 0 because half of the part is above x-axis and half of the part is below x-axis. So this is how the average of this signal would comes out to be 0. So this is the triangular function. Next function is the sawtooth wave. It is a wave like sawtooth, so it can be drawn like this. The time period is again t naught, and power of this signal when we calculate comes out to be a naught square by 3. RMS value be a naught by root 3, and average would be 0. One more function is there, sinc function, which can be defined by sine of pi t divided by sine t. So it is sine pi t and divided by the same angle, that is pi t, value of angle. So it would be sine pi t upon pi t. This is our sinc function. So its value will be 1 at the time instant 0, that is t is equal to 0, it will be 1, and as the time approaches infinity, this amplitude keeps on decreasing and at infinity it goes to 0. Okay, and it will have a infinite number of zeros, as it will be 0 for n is equal to 1 2 3 up to infinity. okay, or n is equal to -1, -2, -3. So at all these points the value would be 0. Okay, at t is equal to 0 it would be 1, at infinity it would be 0, and the magnitude or the amplitude keeps on decreasing as we go from time 0 to infinite or 0 to minus infinite. So it is a even function. As you can see, it is symmetrical about the y-axis, so it is a even function. Okay, so these are some of the functions we have seen in this video, which we will use throughout our syllabus of signal system. So thank you very much for watching this video.